Good evening, everybody. We are back. Try to get in here where we can see what's going on. All right, so got some stuff moved around, so we're going to take and pop the top on this thing. See what it needs. I believe that this well, I hope not. I've got a 1000 amp here that I got to take care of here right behind this, and it is also for the same customer, which that's what he's got on it is simple. He's just got on his 1000 amp power supply where he had it directly wired into his service panel. For whatever reason, he just, instead of unwiring it, he just cut the cord. So we just got to put a new cord on it. So that's an easy repair. Yeah, I've still got to get to you too sometime, Bruce. I did, however, finally find where I put that 100 feet of RG400 that I bought. So that stuff's kind of expensive just to not know where a 100-foot piece is. All right. Just tilt it up. Ah, I see, said the blind man. Alrighty, well, I see why he had problems with this. We're gonna have to get some cleaning supplies before we go too much further on this. So I'll have to slip in the house here for just a moment. But anyways, we have had a worker. Those are droppings from one of the workers, which I'm going to presume, since the copper is green in multiple different places, you know, with all that loveliness, chances are. Yep. So I'm going to take this outside here in just a minute. We're going to blow this out. But yeah, I know that you got one 2-pill section or 4-pill section anyways that has had an issue here. And I'll have to go through and just look and see what else. But yeah. Like I said, definitely going to be interesting. So let me take this just outside the door here. We're going to empty this thing out and then bring it back in here. So bear with me, guys. No, they're HGs. Yeah, those are HGs. There we go. Oh yeah, it's still a lot of money, but Alex said, give me a second here, guys. Definitely gonna need some cleaner. That takes care of that part. Great stuff, guys. Oh man, that sucks. It's a brand new can. I'll have to figure out how to get that one out. All right. All right. One more minute, guys. Hang on. There went most of a can. Alrighty. Well, that try to get that whole thing in there. Man, it's big. Anyhow, yeah, that's the unfortunate whenever you're dealing with the large openings in the back. More than likely, there is large gaps in the front in between the heat sinks. So that's something that we're going to block off, try to take care of so that he doesn't have little mouses running back through his amplifier that are looking to be supercharged. So yeah, that's where he has had some issues. So let's go through here and start looking. A probe here. I know I'm going to have to blow this thing out again, but at least I'm to the point where I can take and actually clean this thing. The big thing is we got to go through here and find some of the issues with it so that I can get an idea of how many to order. This is not a normal 48 pill. This is a 48 pill with 2879 C series. So we're talking another $15, $16 a transistor is what we're looking at. Camera around here. Get some of that glare off of it. There we go. So yep, 2879 C series. So definitely a couple of bucks sitting here. All right. So what we're going to do is go ahead and look at our different outputs here and see. Like I said, I know we've got definitely an imbalance here. So we've got low transistor. So we got low transistors there. Just gonna put a red dot. I think he got shut down where it didn't cause any major issues, thankfully. So that one's going to need to be replaced. This one will need to be replaced. So that's where we're going to start at. Problem there. Apparently, he let off of it quick enough. He didn't even overheat this one. So that's great. The shmoo on it. So we'll just replace that one. The other thing too is we've got, sporadically, we've got screws that are also going to need to be replaced. To just moved in, so as you can see, what the urine has done, and it's just deteriorated that. So we're going to clean this all up and scrub it down with some cleaner. I've already sprayed it once to go ahead and help neutralize that. Jeez, Pete's guys. Yep. So whoever's building a box, whenever put one of these together, please make sure you put your blocks up front, not only to push more air through the actual fins of your heat set, keep Mises and pieces out of your amps. Okay. Early, did you make it back in there, big guy? How a mouse would get in here is you've got channels. You've got your heat sink that sits right here, another heat sink right in the middle, and another one over here. So what it amounts to is you've got a gas, but they're not fully continuous all the way. So what you have is you have on the side, on each side, and you're also going to have a gap here and a gap in between here. So you've got a roughly about a 2.5 inch by 3-4 inch wide gap. And then when you look at the back of the amplifier, you've got these large ports right here. So, yep. So that's how it came in. You know, it was way too easy for him to access this. And that's part of the problem, is he had too much access to it. So, two things that I want to take care of immediately. And the only reason why I say it is because it's just, it's bugging the living daylights out of me. We're going to replace this screw. And there's another one over here that has also started to rust. So we're going to pull those two and replace them. Yeah, a grate would be advised. Again, we're going to go back once we have everything figured out what we need to order for this, because I typically don't keep more than about a pair of the 2879Cs, mainly because I just haven't had anybody that has really been asking for them. So I don't really stock a whole bunch of these. So I'm actually going to order, I'll probably order about 8 more than what I need for this repair, just to have them on hand whenever I go to fix this. But that way, if I have to, I can go ahead and replace, other sections as I go through it, if need be. But, we're going to go through and check everything, like I said, and replace and pull, some transistors here between ports 1 and 2, and go from that point. But like I said, I want to replace those 2 screws just because they're just screaming at me. Once I get that. It has been a very long time since I have worked on anything like this that's had mice inside of it. Jeez, look at that corrosion. This isn't that old of an amp. So I'm going to go ahead and flow this ground out too, since we're right back here. Ground, because of where we know we've already got some issues. Urine that's already stained. I was hoping it wasn't going to be as detrimental as what it is, but apparently we're going to have to use another cleaner. See if we can't neutralize and clean some of that, so we get the solder to take a little bit better. It's not sometimes you can just take the rosin core itself, will just go ahead and burn it off and burn it out, and all will be right with the world. Fortunately, that's not the case here today. Okay. Hey, good evening, Tracy. No, we don't have to use dental floss, but I do like using an ultrasonic toothbrush. It does really good as far as to clean things up. Speaking of which, I'll spray it out. But I use this also on radios as well. All right. Alrighty. Yeah, this. Another thing that we're gonna wind up doing, but we'll do that a little bit later. For all you guys that have Harleys, if you've ever used the Neverdol, this is some really good stuff. Just for example, it's going to take some time. We're going to go back and we're going to probably pull each one of these, remeasure them, and see if we can't get that stuff polished off of it for the most part. But this does really good. But since we've got, let's kind of go over this one too a little bit, that'll help neutralize the effects. A can of this stuff lasts forever. But our big thing is, more so than anything, we want to neutralize any of the green places. That way it doesn't continuously eat away and erode the board. I don't mind this stuff being on there because it's not a big deal, because I'm going to have to come back and do some serious cleaning to this thing anyway. But the big thing is we just got to make sure we neutralize the acid. Anyhow, set that off to the side. Get that. Then we're going to start yanking some transistors, since we know that we've got an issue right there. I'm almost going to feel like I need a shower after this, guys. Jeez. All right. Oh, wow. It's been a while since I've seen this. So we can bring the camera in here a little closer. Bet you won't bet that transistor right there on the end is bad. Of course, our tattletale is a little smoked too, but it's been a while since I've seen on the feedbacks. Come on, focus. Now, like I said, it's been a while. So we're going to go through here with a fine-tooth comb before it's all said and done. We can get this camera to sit back up on stand. Yep, that's exactly what it is, Early. That is exactly what it is. No, they are not. Yeah. No, those are not Toshibas. They're 2879Cs. is what they are, Herman. Yeah, like I said, it's not very often that I see this as far as on the feedbacks. So we're going to go ahead and pull that. All right, so let's pull this section here apart. No, here about a month or so back here, Herman, you'd have probably laughed at me here in the shop. I know every camera would have if I would have been on camera at the time, but I wasn't thinking about the type of screwdriver that I had, which I really should have used the correct type. But where I was working on a tuning coil and adjusting the space, it's got a metal tip on. This goes all the way through because it's meant to actually be hammered on, essentially. And well, I'll tell you what, you talk about getting lit up. Wow. That was absolutely crazy. Yeah, I know. But it's one of those small little errors. Thankfully, it was small enough that didn't hurt too bad, but it didn't let me it didn't let me forget it. We'll say that. Mm-hmm. That is no joke there. By the way, if you get bored one day, Herman, oh, I need somebody to sort all these out. Yeah, I ordered about another $500 worth of silver dip micas the other day for inventory. So who's ready for Turkey Day? Well, you slacker. You'll have to get in the shop and get something done then. Huh, I was wondering what I did with those. You know, that wouldn't surprise me early. Surprise me in the least if they tried. You know, I know we're gonna, you know, the Macy's parade, I think that they have every year for Thanksgiving. I'm sure that's already been canceled. This is definitely one of those years where uh, we just need to take a shot of whiskey and forget this ever happened on New Year's Day. I'm not much of a drinker. I would still do that if it would work. All right, so I'm gonna number these. Lead pencil. I've got an idea of what sections actually blew out, and see if we can't determine what happened. I think it may be obvious though, but there you go. I've seen them online, but I've never had one in the shop. So I don't know. I don't know anything about the individual that's doing it. But these days we've got so many people that are trying to build, and I've been out here doing this stuff for about 27 years, and I'm still a small little mud duck. Oh, okay. Okay. Now, unfortunately, also brings another thing that just caught me. Mr. Bailey, if you are watching this video, hopefully you'll pop up and send us a phone number in contact with you. But your radio's done, big guy. I found an email for him. I sent him an email a day or two ago and still haven't got a response. Typically don't like using email. To me, it's just so impersonal. Okay. Yeah, it's a 5/8 core. It looks like they've got two of them put together here. Looks like common, common inductance that's usually used. Other than this, just a little bit larger. No component detected. Let's see what this one says that was right next to it. Okay, so we got an HFE 31. Equals 5 milliamps. That looks good. Photo collector 5 milliamps. IC leak. That's what I was mainly after, which is showing 0. So in theory, this is still a good transistor. It's showing 31 is the gain. take a little pencil here, and I'm going to put the gain on the bottom. That way, when we go to match everything back together, if we have some mismatch, we can kind of go from there as far as with each other, so that we know that they're going to work. Okay. So that was 1 and 2. Let's go over here to 3 and 4. Just going to go down the line and see what we've got. Oof. And it's a good thing we went ahead and pulled down the next one. Okay. We've got a gain of 10. Gain of 10. I do not think that will play nice with a gain of 31. That's also the million-dollar question, at least with the Toshibas. You could pretty much go off of the gain at basically if it was like 15 and above. You could match them together and knew that they were going to give you some life for a while. Oops. Try that again. And that's a gain of 12. Now that makes me wonder, since we know that we had a problem here in this bank of 4, really makes me want to go ahead and pull at least a couple of more and see where we're at here in relationship to the transistor gain. Okay. So let's go ahead and pull one more here in this section. Then we're going to go over to the other quadrant that we've got marked here. And we're going to pull some transistors out and check that here as well. Yeah, I've got another 2x6 that I'm going to be working on later this week for another gentleman, but he told me that I was able to take my time with it, which will also reflect as far as on his bill, since I'm not going to be pushed to do it. So it's going to be great. I'll be able to get him taken care of here. My big thing is tonight, I just want to make sure I can get the parts on order for this, because I'm not sure if I'm going to have to wait with everything that's been going on with the presidential elections and with the trade from China and all that other good stuff. I may have to wait on transistors, so I want to make sure I've got enough transistors to finish this repair. Plus, I'm out of, after fixing the 6-pill and the little 2-pill, I polished off everything that I had in stock on the standard HGs. I don't even have any put back for builds. Come on, baby. There you go. And we've got a gain of 13. That's in the next 4-pill section that's accompanied by this one. Now, with these being the 2879C series, I know that the gain works just slightly different in relationship to that, especially where we've got one that still has a gain of 30. Was it 30, 31? 31. Okay. Let's see. Not as bad as I didn't want to. Yeah, this is the first time I've worked on anything this large with the 2879Cs. So it's kind of a learning curve on this one. To be brutally honest with you guys, if it was Toshiba's, like I said, I kind of know where to go at with that. Typically, the largest 16 pill in the HG lineup is, 16 is fairly common anymore. You'll see 32 from time to time, which now if you're using it in the house, a 32 pill, honestly, I would actually consider going to steel. To be brutally honest with you at that point, because by the time you buy the amplifier and the power supply to run it, it actually would be more economical. Of course, I know there's a lot of people that, because of the high voltage, it kind of frightens some people. So I can understand that as well. Harley, you still awake, buddy? Didn't know if you got that car fixed or not today. You said you've got to head out, what was it, next week? Yeah, I guess Early's got out of there. There we go. Okay, so we got 15, so they're going up. Let's get this one marked. We're going to pull 2 more. Herman, you still awake out there, big guy? So we'll pull this one and then we're going to go with this other section. So I don't want to sit there and take and pull all 48 of these, especially if there's no necessity in it. This also kind of gives us an idea of how this thing's been running. You guys are quiet tonight. All right. We're back down to a gain of 10. Jeez. Piece of solder stuck in there. And a gain of 14, excuse me. All right. So we know where we're at least in that section. Oh, okay. I didn't know if you were still out there, big guy, or not. I didn't call you today because you said your ears were bothering you yesterday. That's the reason why I hadn't given you a call to touch base with you in a while. Well, John, it looks like we've got you on there. It says that you commented. But yep, if you have missed us, we're still out here just on another video. Okay, let's see what that is real quick. Okay. Well, hello, Tracy. You got me on the TV and on the phone. Wanted to make this thing look that much bigger. It has been years since I've had anything close to this size come in the door. Okay. Jeez, what pace, man. tight side. Go. Yeah, that it is, John. All right. So I've got one out there. 16, and I need to start marking these as well. 17. I'll wash off as far as the pencil marks. Yeah, I've got 8 so far, John. If you've just keyed in with, or just popped in with us, pulled 8 out of the first section. This is broke down into 3 16-pill sections for the 3 16 pill sections, and I pulled the first 8. We've had one that is completely bad, and all the rest of them, the gain has dropped all the way down to between 10 and 10, 12. They're varying all the way through the entire 8-pill section. So that one's 14. So we've taken some of the tattletales that are in here. For example, this resistor here, as well as the one over there, had some discoloration to it, so we know that there is a partial imbalance. This one actually has one of the tattletale 10 ohm resistors. Although they are half-watt resistors, it did actually darken. So we're going to go through here and we're going to replace everything that is definitely known bad, and then start checking some other pieces and parts. And once we get the new lot of transistors in, we'll go ahead and stack those based on where it's going to work out the best. At that point, then we'll go back, we'll key this thing up, we'll find out, if we have any other weak spots that will need to be addressed. So that's kind of where we're at right now as far as bringing you up to speed. Overall, it's a really nice build. I just wish that he wouldn't have had a little mouse try to make this into a house. I think ultimately that's what caused him his grief with this. Tidbit right there. Yeah, the other thing too that I want to take a look at, when we go through here is I'm going to do some counting in relationship to all of our 8-gauge wires that are feeding each 16 pill section, and see whether or not they've got anything in retrospect to unitize these together besides just the one end. So that's something else that I want to take a look at and see what's going on there, and see whether or not we can't do something to combat that. The other thing too is once we get to that point, I'm actually going to put stoppers as far as on each side of the heat sink in between, so that number one, we don't have the same problem happen again, and number two, it'll go ahead and it'll make the air actually force its way through each one of these long pieces of heat sink to keep it cooler for just a little bit longer. We can increase that cooling factor. All right, so there's some of these that they forgot to clean out the holes just a little bit. You know, it's expensive to have things retooled, but these are just a little bit wider than the Toshiba's. They really a little more space on the transistor. Hey, good evening, Charles. I tried calling you back earlier today. Oh, you just watched your 2x6? Okay. Is this one yours? No, it's Mike's. Yours was, I think, the other 2x6 that is going with this one. Yours, I've still got a part. I need to see what I've got to order for this. But yeah, I've got several pieces of wire that we got to go ahead and wire back into yours, and I've got to build the network for the biasing for the sideband. So the weeks till I get my next weekend off. So, you know, like I said, I've got to get parts ordered for this, and that's one of the things too, is I want to get that taken care of while I'm waiting on parts. I'm going to try to finish up because I think that one's yours. And then your power supply's done, the 955. I still got to do the conversion on it, but I wanted to finish the amplifier and get that all squared away, and then go back and finish up the 955. I've got some other things that we're going to do to the 955 that's going to take me a little bit more time on. I think it'll be well worth it. once we get to that stage. Okay, so mark these before I forget where they're at. Oh wow, you've been out there for a long time then. Yeah, I was gonna actually try to work on mine a little bit more and get things dialed in a little bit better. At least I got, at least I got the main part of it done. It's not quite where I want it, but it's usable. I've got to try to get it get a little more bandwidth on the antenna and get it dialed in just a little bit better. But overall, it's a lot better. At least I don't have, 2.5 to 3 standing wave. Wow, 8. Jeez, it beats. $10. Yeah, they are, Charles. They definitely are, buddy. That's part of the reason why I don't have anything permanently put in my little Jeep. When I got my Jeep a year ago, I asked as far as if anybody had one that they had tried putting one into yet. Of course, I also talked to you about the potential of making me a special made bracket where I could actually set an antenna either on it or whatever, so that I could actually put my radio or mount a radio in there on a more permanent basis. I miss not having a radio in the truck. I've went a year without one now. I'd have Early do it, but I can't get him up here long enough to work on it and run it all for me. And the day you come up, you had run off, and you acted like you had a job to go to too. I know that's just part of it too. Yours is just like Early's, though. It'd be a long drive. All right. Well, I've got one more in this section here. I thought I'd pulled enough off, but I guess it's where I've been talking back and forth. So let's go ahead and get this other feedback out of the way. Take this other loose too. Give myself a little more room. Come on, let go. This has got something stuck to the bottom of it. It's been there since it got put in. Okay. Okay. Let's see what our magic number is. 10. Okay. So out of that section, we've got one that dropped all the way down to an 8. Yeah. Unfortunately, I know that you were, on limited time when you'd come up to visit anyways. Yeah, Early was going to try to come up for the break that we had here month or two back. He was wanting to try to come up, but his plans fell through as well. I'm not sure how things are going to go in relationship to the next year. Since we're still fighting, with all the restrictions that they've got going on. So that's kind of it's going to be kind of a unique thing there. To be brutally honest with you. All right, so the good news, this section I thought was bad, it does have one that's very, very low, but out of 4 of them, we've got an 8, a 10, and I think a 14. So that's definitely something to ponder before we go putting this all back together. At this point, I'm actually ready to pull one out of a good location, just for an example. Kind of see what's going on there. We've got another one marked over here, and we're going to go ahead and pull. We're going to go ahead and pull at least one section out and see what we're at on that, and then kind of go from there. Yeah, we really need to know what we've got as a whole, as far as on the gains. Well, Tommy, this gets powered up by a DC source. Essentially, we'll wind up, in most cases, we would build a 1,000 amp power supply to run something like this. I think you can get by with an 800 amp. I'd have to go back and do the math on that. As far as, let's see. Let's just find out here. Yeah. We would need 800 amps to comfortably key this, as far as that full potential. Yeah. Well, if we figure 30 amps for every 2 pill, which once this thing is being pushed up to its typical work level, under a full load, it should draw approximately 720 to 750 amps. Now then, to go above and beyond that, like I said, that's pretty much your minimum is the 800 amps. So to go up to the, full potential, especially with this being the C's, this is based off of the other ones. So, we could easily go to 1,000, 1,000 to 1,200. That's not really unrealistic. Okay. Oh yeah, you definitely want to have more. That's one of the biggest things that people ask me, well, how much do you need to run it? Well, it depends on the amplifier. For example, oftentimes, for a small amplifier, 150 to 200 amps is quite common for 6 or an 8 pill, and then you go up from that point forward. And again, our biggest thing is you're always better off to have reserve power, especially when you're using these modules. 1,000 amp power supply, really and truly, it wouldn't hurt to have, even if it was only set up for another, 80 or 100 amps, especially at that point. That's kind of a mute point, if you will. An extra 100 amps really isn't a big deal at that point. So, it's just like a 64 pill, which, again, at that point, you start figuring the cost on building one of these from scratch. If you're going to be running it as a base, truthfully, the best thing you can do is go one step further and just go to the tubes. Because by the time you have the power buy this amplifier, you could have bought a, 4CX, 3CX 20,000. Yeah, that's a little big for this, but yeah, you know where I'm going at. I think you could do what 4CX, like 4CX 15. I'm not too up to date on the tubes, so I've got people that's pretty much what they specialize in. When somebody asks me, I usually will get with them as far as on numbers and what would be a good amp to do with what they want. This one is not cooperating. Yeah, they are. The 4CX 800, I mean, you're still looking at 2,500. I mean, it's not going to be the equivalency of this, but that is more than enough Let's get out there and talk skid. Because you're looking at roughly about 2,500 RMS, about 6,000 PEP. There you go. Yeah, I've built a few of those now. That, especially with the HGs, the first one I did, that one actually kind of had me a little nervous, to be honest with you. You know, especially with these HGs, because of, you know, the fact that you've got a large amount of money. They still weren't what I would call, you know, battle tested. You know, they're definitely a pickier transistor on one overall. Granted, no amplifier likes standing wave, but the HGs really don't like it. One silly thing. Right, this one's going to be a contrary. All right. This one, I'm going to set it back down in there because I don't have any of these marked yet. Oops. And we've got an HFE of 10. Okay. Not here out of the crevice of this thing. So just kind of randomly pulled one out of that section. Okay, so I should make this 32. Okay, so what I'm doing is I am marking these as we're going along. That way I can kind of tell where the weak spots are. Oh boy. Well, that really has me concerned, guys. Wouldn't be so bad if I wouldn't have had one still show 30, a gain of 30. All the rest of them have been so low. I know typically with the regular 2879s, gain of 30 is what they usually start at, 35-ish, I think. Well, no, about 45, so 30 to 35. Typically after they've ran for a while, that's fairly common. My big concern again has to do with these low numbers. I haven't been having too many people ask about the 2879Cs as of yet. We're doing good, Squirrel. Like I said, I haven't had too many people ask in relationship to the Cs as far as to build with. So, like I said, I haven't built with just a few of them. They've all been the small ones. Butterfingers. 1000 amp should run this comfortably, which I've got one here. I got to put a new cord on it. I've got to get the measurements off of that this evening, so that whenever I go to town, either Monday or Tuesday, wholesaler that we've got here in town, well, not my town, but the town that I work in order to go ahead and pick up the cable I need for it. So we're going to pull another four pill section here. So I got that one marked. Just set that off to the side. Yeah, pretty much. Well, 600 amps is all the bigger my power supply is. I mean, I'm able to run pretty well everything that I need to run off of a 600 amp. You know, like I said, I don't normally work on things this large. I mean, if this becomes something regular, I'll have to sit there and break down and build me another power supply. holding this little thing yet. So there's been one or two that's actually fit, but it's all kind of tight. There we go. There we go. And those off and check them. This is actually a Fat Boy box squirrel. Yeah, they were the ones that actually originally built this. Doesn't look like it's been messed with or tampered with since. It's just he had some visitors come and help him out on the inside of it. Got a few little mice get in there and wreak havoc. Yeah, they can ruin anything, that's for sure. So I'm going to go ahead and just do a quick cleanup, and then we'll go back to the rest of those transistors. But yeah, I'm going to have to find something that I can use to go ahead and neutralize what they've done. And some of what they've done. And some of the cleaners that I've already put, but I'm going to go back through again and actually look and see what else would be best. got that over with. Wipe these off and we'll see what kind of gain we've got left. All right. We've got another gain of 10. Another one at 10. Seems to be the consistency right there. And a gain of 11. I think that's showing up. Okay. All right, so we've got one bad one that's apparent. We've got another one at an 8. A lot of them have been running 14, 12, 14, 15. We've got a lot of them that are 10s. Let's kind of look and see what we got here. 10. That one I didn't write a number on. It's out of the first batch that we pulled too. This may be the bad one. Okay, 12. So 10, 12. And that one didn't get marked on either. Well, there's a couple different reasons for the tuning tubes versus, an actual fixed capacitor. Okay, 13. Let me get this marked here real quick, and then we'll go into some detail. Okay. Part of it has to do with trying to find a specific, specific value. That's probably one of the major things. The second reason is cost. It's more effective to buy these tubes at about $8–9 a piece when you buy in quantity. It's cheaper to actually buy these than what it is to buy a doorknob. A doorknob capacitor, for example, especially to hold the equivalency of a 16 pill in this particular case, you're looking at anywhere from $35 to $50 a piece, versus, or again, about $8 to $10. That's one reason. Yeah, that's another thing too, is the power capabilities. The tuning tubes can take a lot of abuse as far as power is concerned. That's another good point too, early. The actual rating on the power itself. That makes a huge difference. I think more than any of it, though, is the two major things, which is cost effectiveness for number one, and number two, to fine tune something. That's what's really nice about these, because the fact that these are variable, based on how far in or out that they are, allows you to go ahead and fine tune for just that right amount of physical input or output, depending on where you're at in the box. It allows you to go ahead and get that input tuned down like it needs to be. It allows you to get the output tuned exactly where it needs to be. You can do it a couple of different ways, but cost is a lot of, I know the last 24 pill that I built for a guy, the doorknob cost $56, which was the better way to go. Now it still has a tuning tube in there, but that was to actually go ahead and fine tune that last little bit to get me exactly to where I needed to be. So, but the doorknob takes the brunt of it. Anytime that you can add, and there again, you take even, for example, a DM15 or DM19, it can't handle the stress like these tubes can. Whenever you start getting into a large amount of output power, the input power, yeah, it's a little easier, but you're also, you also have to remember you're splitting your output power. Like, for example, in this case, you're splitting it into 3 inputs. You can get by with a lot at this point. Up here, now that's a little different. As far as on your LC network that's up here on your input, you have the brunt of it that's being soaked up by your one tuning tube here. Again, because of the fact that it can handle the stress, and as well as give you that fine-tune adjustment. Once it goes past your LC network and goes into your 3-port combiner, from that point, it goes out to 3 different ports. Oh yeah, a vacuum variable would be absolutely awesome and would be one of the best. But I'm sure early that you've looked at it, and for certain amplifiers, here, okay. For example, here we have a tuning capacitor. This is exactly what Early's talking about. These are absolutely the bomb. But you're also looking at, depending on what size you buy, this is actually one of the best ones that you can get. This is a Jennings, and it's not so much the fact that it's a Jennings as the fact that it's a vacuum air variable. For example, if we put this in here like so, take the tailstock off, which we could do. That takes up a lot of real estate for what it is, but you're also looking at $300-400. So $300-400, maybe 20-25. Huge difference in cost. Yep, they are definitely high dollar. I think to replace that one, which it goes from, that one's really an incredible one because the fact that it goes from, I think, right around 15 puff on the low end all the way up to 500 puff. There again, because of the enormous range that it has. So, the enormous range that it has, that actually contributes to a lot of the physical cost of it. But it's also rated for 15 kV. There's your question. Like I said, there's multiple different reasons why people use it. And, like I said, one of the number one reasons most of us do is just for the physical cost. That and trying to find specific values for each input or each output. And the doorknob, which is a great capacitor to use. Like I said, it is so hard to actually buy one that is the exact value that you need at that time. Sometimes, some of our tunes, you can only vary maybe 10. Alrighty, so back at this. All right, so we've got these 8 out here. Before we get off on tangent, these over, we've got 10, 12, 13, 14, another 10, 15, another 10, 10, 10, 10, 11. That one didn't get marked on, so that should be bad. 8. Set that one off to the side. 10. That's the odd duck out. 31. 12. This one will mark it just as soon as we check it again. So this one should be the bad one because it's in the number 1 location, which I know it's bad right there. Usually I'll mark it with a B. Yep, no component detected. Now, since all these others check like they do, we're going to go back to the odd man out at 31. Make sure I didn't transpose any numbers. Yeah, 30. Okay. Believe it or not, the ambient air will actually change these by about one digit, or depending on which end of the leg that you test on. 30. Okay. So we've got one one bad one, one with an incredibly high gain compared to all the rest of them. So now we have one of a couple of choices. At this point, sometimes it'll be higher, sometimes it'll be lower. That's just like your capacitors. This was something I know until about 5-6 years ago. It was something that was never brought to my attention, and I played with it because I had found out about it and thought, yeah, okay, you know what? So I don't have one laying here. All right, let's just randomly pull one out and I'll show you. Okay, just a simple capacitor. All right. Okay. All right. See if we can get this up here. All right, so all right. Now we're going to take our metal probe. Okay. Now you're seeing it go up to 9.7. 10. It's hard to hold this, or even your finger. There it goes up to 10. Even though I'm not touching it, that's actually changing it. Now we're down to a 9.3. But the physical spacing on your capacitors itself actually change based on heat, moisture, obstructions. So that was one of the little tidbits that I never really knew about, or never gave it much thought. I'll put it that way. You know, because I mean, you can make your own capacity piece of aluminum foil and a piece of paper to be quite but the physical spacing, that's the reason why a lot of people, what they will do, include, for example, if I'm going to mount this in, that's the reason why we bend those out, is to separate, or they will make the legs as short as possible. And what it amounts to is the shorter you keep this, or keep them, you actually have less ambient temperature, because air is nothing more than a capacitor. So your airspace will affect your amplifier because of the change in the temperature. Like I said, it'll actually change the value on this capacitor, and it's not just the DM15s or 19s. You know, as far as on the silver dips, it's even your metal clads, your tubes, all that goes into play. Speaking of heat, I'm going to turn the heat up just a little bit in here. temperature's dropped enough outside that it's actually getting quite cold. All right, so I think what I'm going to do is I'm going to pull one more transistor. We're going to go for an easy one up in the top corner. The only reason why I'm going to do that is I've got a nice bright shiny resistor here. I want to see whether or not our consistency is going to stay the same here. Some that are odd man's out. We've got a bad one. I definitely have to have at least two. And the only reason why is with this one being so far out of gain, it's not going to play well with any of the others. You know, we've got two of them that's 14, 15. Those two should play well together. Same thing with the you know, the 12s. I've got a pair of those. The 11 and 13, since there's only two, those should play well together. But we're actually going to group these back together based on what they are when we go to do the install. But I want to pull one more and see that's completely an opposite end of what we've been working on. And like I said, the only reason why is I want to have a confirmation on my AHFE. Then I'll get with the customer tomorrow and find out, based on what I find, does he want me to replace all of them or just replace the ones that are bad? So that's kind of that point. Because repilling this would be incredibly expensive. Yeah. $64 feels good. Well, it's not 64. It's more like 44 here. It's kind of where we're at. Okay. And we'll go through and replace all these pill screws too while we're at it. I bought a few pill screws. I actually bought 10,000 of these, believe it or not. This is only half of them. The other half are sitting over in Texas. All right. Wished all of them would come out like that one did. Okay, so we got 14. All right. So 10 to 14. You're lucky to do 1,000. That's about all I've got right now that I've been running here in the shop. I don't know why that thing's wanting to be blurry now all of a sudden. There we go. All right. Since we know where we're at there, let's just go ahead and clean that up while I'm at it. There we go. Wasn't sounding just quite right. All right. Let's go ahead and replace the parts that we know we've got to replace. 5-watt resistors. Not really anymore. I used to a long time ago, but most everything around here that I've done for the local people, most of them have all been what they call the old sweep tubes. That's what I originally started out with, even long before the transistorized stage. So, you know, yeah, I kind of do, but I really try to avoid it as much as possible anymore. You know, to be brutally honest with you. Okay, I wonder if I've got any of those that size. I've all but quit carrying those. Usually just stock the 10 ohm or the blue ones, because the blue ones are actually a 1% tolerance. So this is the section that I want to look at the hardest. Make sure everything's secure there. I'm also going to pull these off and check. It may just be the fact that the one gave up the ghost. So I'm going to check these and find out. Where we're at. Well, it's not the fact that I'm all that hard-headed. Okay. A lot of it is I have not stayed up with it enough to know what I'm looking for in relationship to parts, as far as finding parts. Okay. There's that. Looks like I'm gonna have to put some new batteries in this thing. It's telling me the batteries are low. Check it now that I know what the value is supposed to be. Okay. Okay. And they're well within their range. Okay. That's within the range. No, I don't want you to have that, that's for sure. I'll never be able to talk in Indiana. Okay. Get my soldering iron down in there. Okay. Get close enough to that that one's good. All right, so I think we just had a pill that just didn't want to work no more. All righty. Place the batteries in that. Okay. Pull that out. Okay. Okay. That. Just so happens. Sadly, I gotta buy some more of these.
Add a little more solder before we get too rambunctious.
Okay. Looks pretty good on that one. I am not mean. I may get into the steel tubes, but that's going to be a little while down the road. I got 2 irons in the fire right now to take on a whole nother building. Plus, like I said, I got to find some good resources as far as for transformers. Transformers, the tuners. Some of the other stuff that's more proprietary to tube type. In certain aspects, it's actually easier, believe it or not, in certain aspects to build with tube type equipment. Components of sorts. One tube that takes the place of 48 transistors. I don't know. I haven't seen any of them. Anything about them. So I couldn't even begin to speculate. Okay. go. All right. Takes care of that bad one. That one. Place that one. The rest of these, I think that's just stuff cleaner needs to take care of. I think I am going to change that one out just for good measure. Okay, so let's put those up. Okay. I'm actually surprised, as large as what that area is, I'm actually surprised that they didn't put the resistor inside versus on the outside. And there's a little checking there on it. So that one did get a little warm. Say this is the only one that I've seen that really didn't get soldered as good as everything else is on this. Okay. Let's go down through here to check, make sure everything. Everything else looks like it's really good. That replaced, that replaced. Okay. Let's check some of these resistors. Make sure these are all taken care of as far as the little tattletales. Make sure none of them look off, discolored. Okay. Everything else looks good.
Oh, so you're down there in North Carolina with early then, Squirrel. Okay. Not sure how well some of this is going to clean up or not. Yeah, the only real concern I've got is not for the beauty's sake, although that is nice. Just what we got here. That's what we're after, is just to neutralize that green. Panama City, huh? Okay. Man, guys. Okay. We'll move off of here. Okay. Let's just sit and see what it does tomorrow. On that part. See if we can't get some more of that off of there. Crud. Actually surprised we didn't find a whole mouse inside this thing somewhere. Jeez, oh Pete's. That's what I'm surprised of. One heck of a big combiner. Jeez, oh Pete's. That is definitely a big mamma jamma. Actually, that's one of the things I was going to get early is some white vinegar, because white vinegar is a great neutralizer, and I should have some in the house, but that's something else that I want to try as well. Because like I said, if I don't, you know, I know he hasn't had this box quite a year, and depending on when this actually happened, if we don't neutralize it now, especially with some of the large places, they have apparently been trying to nest at some point, and with the large areas back in here that you're seeing, if that doesn't get neutralized, it's literally going to eat the copper off the board, cause huge amounts of problems. So bear with me. I am going to go in and get a gallon of that, and that way we can get it dabbed on here and see if we can't help get this to turn back to the copper, or at least, like I said, you know, just neutralize it. That's our primary concern. Good evening, Charles. How is it in the hood? All right, guys, give me just a second. Alrighty. Boy, that vinegar feels good on a cut, doesn't it? Lord have mercy. Wow. One spot there that's in between the transistors. It's the only spot that I've seen as far as in the main sections that I think they've made any kind of issues. I think part of what's helped it though is what rosin was left in the solder. Yeah, once we get this all taken care of and neutralized and cleaned back up, we'll go back once we got the entire thing repaired. We're actually going to go back and I'll re-clear this, which will help immensely. I may even have to go one step further on this and take and actually bathe it. Scrub it down again really good. That's the biggest thing we want to do is just neutralize it. All right. try and clean this as well. I don't know what the extent of the aluminum that they've got. Although aluminum does not rust, it does oxidize. And with the right stuff, basically the oxidation is its type of rust. It will actually deteriorate a hole through it. Same thing with copper. You know, anytime you're dealing with, you know, any type of metal like that, there's always some form of rust. Some of these places are just so heavy. With a little time, let it sit there in tuning coils and immerse those in white vinegar for several days. I don't care if the vinegar sits there and dries overnight on it. With that, all I gotta do is just take a damp cloth and wipe over it. This is one place over here, though, that really alarms me, since that's where the main ground for this amplifier is. You could, as far as like a small buffing wheel. but you're also talking about hours and hours and hours, and that's not practical. At least as the individual repairing it for somebody. Now for yourself, it'd be a whole different story. You can polish on this all day long, but when you're repaying somebody, that gets quite like this and polish, and then have to go back and try to clean it. It's just not 100% practical at that point. So, all right, so I'm gonna let that sit on there for now. All right, so we got the resistors taken care of as far as that needed to be replaced. I'm going to call the customer tomorrow before we go putting everything back together on this. So that part we should be good at. All right, so what else can we get done? We already tested those, since that was our main bad section. What a little bitty microscopic cut. Boy, it burns. All right. Well, I'm hoping that things fall into place like they're supposed to, at least on that part that you guys are talking about. All right, so one of the other things I wanted to check out, we've got 1, 2, 3, 4, 1, 2, 3, 4, 8, 9, 10, 11, 12. So we've got 12. I'm sure. Okay, 1, 2, 3, 4, 5, 6. 2, 3, 4, 5, 6. All right, so that means half of one of these is in this and half of the other one. All right, so we know we've got 2 separate connections. So that's one thing we need to address. We also need to address our cavities, so this doesn't happen again. All right, so let me see what I've got. Strap. Perfect on that side. I'll knock off our 2 ends. And we'll have to figure out height. Just as large enough that way. All right, so let's get some measurements. All right, so 3 5/16. Just is plenty long enough to take care of those 2, which that's what our main concern is. And the 2 on the ends, if I have to, I'll find a different type of material. So let's go ahead and cut this, get that squared away. All right, let's be in here. You need some more ground lugs. There is no way you went through all those. Speaking of which, though, I don't know if you noticed the cost of those here the other day. Those things have went crazy. Wow, 3.5 hours on this thing. Okay. Okay. Alrighty. Now we've got our two big positive blocks off that were roughly 3 inches. Those two blocked off so we don't have those ginormous air ports that we had to deal with. So that's one of the main things that we wanted to take care of. Now we've still got our openings on the end, so I'm going to have to look and see what we've got left as far as miscellaneous material, so we can try to put something and block those off as well. Yeah, it should. Oh, you use the big ones. Okay. I think I sent you some like this, didn't I? The other day early. These are bigger and they've got a lot more surface area, which makes it a lot easier as far as on the. I've also got these. You know, they still have to be drilled, but I've also got these as far as for standoffs. So, for example, instead of using those tabs like they did there, you know, I can actually set that right in front of or right behind, solder this to the board, and then set it right in here. I can either use one or two, depending on the circumstance. I've got some short ones and some long ones like this. Now those were actually fairly costly to make, because those I actually had special made for myself. Which ones? The brass ones or the other tabs that I showed you? Because the other tabs that I showed you, I bought those actually from a company that was going out of business. Okay. Okay, back to project at hand. We need to find some more material. That's just like the other day. I bought some of these. I thought I would try them. You know, kind of like the ones that I make, where I buy the material and then I actually cut the flats. These have already got the flats pre-cut, and they're already pre-tinned. So I bought some of these too, just to try these and see. I think the material is just a little bit thicker as far as this way, but like I said, I thought I'd try some. I'm not going to run out for a while because I've still got all these that I've got cut up. So these are all course, these are for the 16 pill, which, for example, on this one, I really like using these versus using two 8 pill strips. So, but these I've already got cut up. Like I said, I'm not going to run out for a while, and I've still got several that I haven't had time to go out to the garage and put in the cutter to, make all my strips. All right. Yeah, I save almost all my pieces. Believe it or not, I actually use an end mill early, and I use it in my drill press. Is what I typically do. I won't have so much to pick up later. I know there's times where you'll spend half a day to a day just cleaning. I think this is the most I've used my big soldering iron in quite some time. Normally I'd put something like this in here while it's being built. Instead of pulling everything back out, okay. There we go. And we've got all 4 holes that were exposed for the critters. Now they can't get in. Not that way. Doesn't mean that we can't get other types, but apparently wherever this was at, in the home or what have you, definitely had a problem. Okay. So the other thing too, since we've actually got these, we're actually going to do some testing here. I want to find out whether or not we've got continuity on each one of the positive rails, since we've got 2 plugs and we've only got 12 cables. So okay, so that's actually a good thing. And that's a good thing. All right. So that alleviates actually going ahead and putting a bridge across the front here to go ahead and make sure that all 3 of them are synced. So we've got at least one from each one of these that's going to the eyelets, so that we've got distributed power regardless of whether they lose one wire, which is incredibly important. All right, so we're good there. We went ahead and reflowed the braid, got that cleaned up. So we're going to let that other stuff sit here and do its thing, and then we'll go back and clean the board here over the next few days. Go ahead and allow plenty of time for the vinegar to go ahead and take effect. Which the board's actually looking a lot better. I don't know if you guys can really see that or not. Oh, Amy's going to clean up your shop? Oh, good Lord. You're in trouble now, buddy. You are in trouble now. But yeah, this is not quite back to copper color, but we've got all the green off of it as far as here. Like I said, we'll do this over the course of the next couple of days, and allow for that to go ahead and completely neutralize that. And then, like I said, we'll go back, we'll clean the board again. When we finish the repair, we'll go back and re-clear coat it, and that should take care of any other issues. So the only other one that I see that we need to take care of is right here. is where that head's actually starting to rust. I'm going to pull that out. I'll go ahead and grab another new screw. There's another new screw in the board there. Actually, let's go one step further here. Since I know we had a problem right around that, the last thing I want to do is lose continuity. Okay. I can do that, buddy. So, our gaps filled. We've already checked power leads. So we're good there. Piece of solder there. Okay. Alrighty, so I think we're ready to actually just start putting transistors back in. Like I said, I'm going to stop here. I'll get with the customer, find out tomorrow, and then that way I can go ahead and get his parts on order, and we can take it from there as far as finishing this up. So, all right, guys, I'm going to go ahead and close with you for the evening. So, you guys, I appreciate you popping in and staying with us, especially considering the fact that we're going on a 4-hour video here. So, definitely appreciate it. So we're going to take a bye, and I'm going to get cleaned up, get some food. Yeah, we'll come back. Probably about 2 weeks. And we'll come back and we'll get this finished up. I've got a straight 6. Yeah, a straight 6 pill. I'll be working on off and on throughout the next couple of days. So, all right, everybody, appreciate it. Thanks for hanging in there. Catch you on the next video.